Okay, so let's use this short video to talk about what is partial fraction decomposition. So in algebra, partial fraction decomposition, or in the textbook it called partial fractions, and mainly it's talking about you're working on a rational fraction, and so this is an operation that consists of expressing the fraction as a sum of polynomials or one or several fractions with a simpler denominator. Okay, so it sounds a little bit abstract, but let me show you one example right now. So for example, if I have 5x minus 3, let's say, over x squared minus 2x minus 3. Okay. So you can see that this is a fraction format. Okay. And from the denominator we can write into the corresponding factor form, which is x plus 1 times x minus 3. Okay, so this is a rational fraction, and it turns out we can rewrite this into 2 over x plus 1 plus 3 over x minus 3. Okay. So as you can see that we are expressing this fraction as a sum of two fractions with simpler denominator, right? As you can see that the denominator is actually it's a factor of the original denominator. So this process from here to here, this is called the partial fraction decomposition. Okay, and now why we introduce this? Well, because if we have one integral problem like this, using the U substitution, it will not work for this. But if we can do a partial fraction decomposition into this way, so the integral problem we have now becomes an integral of 2 over x plus 1 plus 3 over x minus 3 dx, right? So it turns out that this integral, it is very easy to evaluate. That is 2 ln of f squared of x plus 1 plus 3 ln of f squared of x minus 3, and then plus the absolute constancy, and we're done. Okay, so that's why the advantage of partial fraction decomposition. And then another very natural question students might want to ask, okay, how do I know this can be decomposed into this format? I mean, we know the denominator is part of the original denominator, that's okay, but how do I know where's 2, where's 3 from? Okay, so in this short video, I'll go through the process very briefly. So for here, 5x minus 3 over x plus 1, x minus 3. We know this can be decomposed into some constant number, let's say a over x plus 1 plus b over x minus 3. Okay, so those a and b are unknowns. Okay, I already tell you that a is 2, b is 3, but let's see how do we get those a and b. Well, the method is very traditional here. You take a look with what we have here. Now the two sides are identical to be the same thing, right? So if you can make the right hand side to have the same denominator as the left, that is, if I have a x plus 1, if I multiply x minus 3 over x minus 3, okay. And similarly for b over x minus 3, I multiply x plus 1 over x plus 1. So right now, you can see that since they have the same denominator, I can combine those two fractions into one. But don't forget that the left-hand side and right-hand side are identical, right? So if I simplify my numerator a little bit, so it's ax minus 3a plus bx plus b over x plus 1 times x minus 3. And then I can re-simplify again to b minus 3a, okay, into this. Of course, the left-hand side is the same, da da da. Let's do 5x minus 3 over x plus 1, x minus 3 here. Okay. So now, things become very straightforward. You know, the denominator are same. So the coefficient in front of x, which is a capital A plus b, it must be 5. And then those b minus 3 is a constant, it must be negative 3. So that gives us a plus b is 5, and then b minus 3a is negative 3. Okay, so this is a system of linear equations, and you know, it's very easy to solve that. A equals 2, b equals 3. Okay, so that's where this is from. About how to solve this, well, actually you can use the first minus second. So, well, let me show you here. Label this. So if we use 1 minus 2, it's gonna give us a plus b minus b minus 3a, right? Equals 5 minus 3. Turns out this is gonna be b minus b is gone. So minus become plus, so it's 4a equals 8. It's very easy to solve a equals 2. When you solve a is 2, b is 3. Okay, so that is a simple example about how to find those 2 and 3s. Okay, so in the following videos, I'll start to introduce more about the partial fraction decomposition. Okay, so I hope you enjoy this video. Thank you.